The Jurassic period, also known as Jura, is perhaps one of Earth's most fascinating eras. Many imagine a world dominated by giant T-Rex dinosaurs, especially after movies like Jurassic Park. However, the reality of the Jurassic period, also called the Age of Reptiles, was far more complex.
This second phase of the Mesozoic era was incredibly long and intricate, beginning 201.1 million years ago.
It lasted for approximately 56 million years, a vast span of time for life to evolve.
The name Jura originates from the Jura Mountains in Switzerland and France, where early fossils were found.
The Jurassic period is divided into 3 stages: Lower, Middle, and Upper Jurassic. The Lower Jurassic, from 201.3 to 174 million years ago, saw life recovering after a major extinction event. This Triassic-Jurassic extinction wiped out about half of Earth's animal species, leaving ecological niches open. The warm, humid Jurassic climate quickly facilitated life's recovery, with oceans teeming with diverse marine life. Ammonites, belemnites, fish, and various marine reptiles flourished in these warm waters. On land, reptiles, including dinosaurs, rapidly filled the vacant ecosystems left by the previous extinction. Some reptiles even evolved wings, taking to the skies and marking the golden age of their kind. Hundreds of dinosaur species emerged across all continents, including Antarctica, reaching incredible sizes. Some evolved into strange and fearsome forms. These prehistoric reptiles remain a great mystery to humanity.
Dinosaurs of the early Jurassic are among the most fascinating aspects of Earth's ancient past.
During this period, the supercontinent Pangaea began to break apart into separate landmasses.
Shallow seas gradually filled the gaps, and continents slowly took on their modern shapes.
Deepening gulfs separated Africa and Australia, while the Atlantic Ocean widened between Africa and the Americas. In Eurasia, depressions like Germany, England, Paris, Spain, and Siberia were formed. The North Arctic Ocean also flooded the northern coasts of Laurasia. The Rocky and Andes Mountains began to form. The separation of tectonic plates was accompanied by intense volcanic activity, releasing vast amounts of CO2. This increased the greenhouse effect, making the Jurassic climate 5 to 10 degrees Celsius warmer than today.
Atmospheric CO2 levels were 4 times higher than current levels, leading to more intense rainfall.
Earth's climate was tropical and subtropical, with vast areas covered by lush vegetation, mainly dense forests. The dominant flora included seed ferns and non-flowering woody plants, unlike modern flora. Plants were more fortunate than animals, with no clear evidence of extinction during the Triassic-Jurassic transition. High temperatures and humidity allowed forest trees to grow tall and large, creating dense canopies. Cycads were common in tropical and subtropical regions, reaching their peak diversity in the Jurassic and Cretaceous. Botanists even mistook cycads for palm trees due to their similar appearance, highlighting their unique form.
Additionally, ginkgo trees, with their distinctive fan-shaped leaves, thrived in temperate climates.
However, only one ginkgo species, Ginkgo biloba, survives today, a living fossil from that era. Alongside cycads and ginkgo, prehistoric conifers also flourished, resembling modern pines and cypresses. These conifers changed rapidly and diversified during the late Triassic and early Jurassic periods. In East Asia, The extinct conifer podosamites predominated, unlike most modern conifers. Podosamites had broad, ordinary pine-like leaves and shed them seasonally, adapting to the changing climate. The rich flora created favorable conditions for an explosion of animal life, especially insects.
There was no evidence of insect extinction during the Triassic-Jurassic transition, allowing them to thrive.
Thus, Jurassic forests, grasslands, and riverbanks teemed with insects, including predatory dragonflies. Imagine dragonflies hovering over water, plant-eating beetles gathering in thickets, and spiders ambushing prey. The first butterflies appeared during this time, though they weren't as vibrant as today's species. Some creatures resembled modern butterflies, but were not true butterflies, a marvel of convergent evolution. These Jurassic forest flyers looked, flew, and even pollinated like butterflies, yet belonged to a different insect group. They were more closely related to modern lacewings, showcasing how different species adapt similarly. At that time, flowers were almost non-existent, with only small, insect-unadapted blossoms. However, gymnosperms like conifers and cycads, containing nectar, attracted these false butterflies.
Convergent evolution is when distantly related species develop similar traits to adapt to similar conditions.
That's why unrelated species can look identical, even when living in different regions.
Tenrecs resemble shrews, moles, hedgehogs, or even otters, making it hard to tell them apart.
If you place a tenrec and a hedgehog side by side, finding 10 differences would be challenging. However, tenrecs are more closely related to elephants than to hedgehogs, a surprising evolutionary link. Similarly, Jurassic false butterflies had broad, scaled wings with camouflage, mimicking true butterflies. But they belonged to completely different orders, demonstrating evolution's efficiency in finding optimal paths. This means if we find a distant planet with Earth-like conditions, we might encounter strange yet familiar creatures. During this time, amphibians gradually gave way to reptiles, with many species becoming extinct.
Only salamanders, primitive frogs, and worm-like caecilians survived the transition.
Among the large amphibians, a few brachiopods persisted, often growing up to 3 meters long. The record belongs to a fossil found in Lozo, Africa, estimated to be about 7 meters.
Throughout history, Perionosuchus was the only giant amphibian, but it appeared and went extinct in the Permian.
Brachiopods had flattened bodies and shovel-shaped heads. Their mouths had sharp teeth, instantly killing prey. Although flourishing in the early Jurassic, their numbers declined as reptiles rapidly diversified. Before dinosaurs became a separate group, reptile diversity surged, dominating land, sea, and air. True monsters inhabited the warm tropical seas of the Jurassic, appearing fearsome, yet wondrous. After surviving the late Triassic extinction events, they gradually recovered and thrived. One of the most prominent species was Ichthyosaurus, or fish lizard, a remarkable marine reptile. There were many different Ichthyosaurus species, typically ranging from 2 to 4 meters in size. However, due to favorable conditions, some species evolved to colossal sizes, like Shonosaurus, up to 15 meters. The absolute champion was Shastasaurus, reaching an astonishing length of 21 meters. Some Ichthyosaurus species had very strange appearances, with shark-like bodies but long, narrow crocodile-like snouts.
They could be seen as a bizarre joke of nature, similar to today's platypus.
A notable feature of Ichthyosaurus was its very large eyes, protected by a bony ring. This allowed them to hunt at night and dive to great depths, with eye diameters up to 25 centimeters. Odontosaurus could see at depths of 1,600 meters, while humans only experience complete darkness at 600 meters. Paleontologists suggest that at 800 to 950 meters, light intensity is only 1% of midday surface light. While reptiles dominated land and sea, in the sky, pterosaurs like Pterodactylus emerged in the Triassic. They became common in the early Jurassic. Despite some extinctions, long-tailed Rhamphorhynchus pterosaurs continued to thrive.
They primarily fed on fish and small animals, showcasing their adaptability in the ancient skies.
Terrestrial reptiles in the Jurassic diversified more than ever. Prehistoric turtles resembled modern ones. But the dominant group on land was, of course, dinosaurs. Paleontologists identified over 900 genera. In the early Jurassic, dinosaurs quickly occupied vacant ecosystems after the extinction event. There's a common misconception that all dinosaurs were gigantic, but they came in all sizes.
Some were as small as chickens, while others evolved into colossal monsters.
Most dinosaurs were carnivorous, hunting for survival, while herbivores moved slowly, grazing on vegetation. Around 82.7 to 74.1 million years ago, a unique herbivorous dinosaur lived in what is now Zimbabwe.
This was Volcanodon, a sauropod with a typical body structure, sturdy legs, long neck, and tail.
It was one of the first dinosaurs discovered in Zimbabwe, its Latin name meaning volcano tooth. This name came from its fossil being found in a sandstone layer, sandwiched between ancient lava flows. During Volcanon's time, the Pebbly Arcos Formation was a hot, sandy desert, not ideal for life. However, plant oases, some rivers, and scarce water sources still existed. Volcanodon was about 6.5 meters long, 2.5 meters tall, and weighed 2.5 tons.
Some researchers suggest it could reach 11 meters long and weigh up to 3.5 tons.
Despite being a herbivore, Volcanodon was not immune to becoming prey for contemporary predatory reptiles. Evidence of it being hunted appeared with the first fossil discovery.
Paleontologist Michael Rayath found a tooth near Volcanodon's pelvis, but no skull or neck. The shape of these teeth resembled those of predators, suggesting Volcanodon suffered greatly when killed. This caused its head to fall near its pelvis, a phenomenon also seen in other dinosaur fossils.
Because of these strange teeth, this herbivorous dinosaur was named after its killer's teeth.
While Africa had Volcanodon, North America's dominant predator was Dilophosaurus, living 199 to 198 million years ago. This formidable predator, with high speed and agility, hunted small herbivorous dinosaurs. The name Dilophosaurus, from Greek, means two-crested lizard, based on its two bony crests.
Scientists believe these crests were ornamental, playing a role in attracting mates, similar to modern lizards.
Dilophosaurus was up to 7 meters long, 2 meters tall, and weighed about 400 kilograms.
This was impressive for an early Jurassic carnivore, making it the largest predator of its time. Some scientists even called it the T-Rex of the early Jurassic, due to its size and predatory nature. Despite its danger, Dilophosaurus couldn't easily take down armored dinosaurs like Celadiosaurus or Sarcosaurus. They would hunt in pairs or packs to overcome larger prey, showcasing cooperative hunting strategies. For smaller prey, Dilophosaurus was a formidable hunter. Its long, narrow jaws quickly snatched victims. With high speed and agility, it could capture small, nimble dinosaurs like Scutellosaurus. Fossil analysis of Dilophosaurus jaws suggests it could also eat fish and aquatic creatures. Sometimes, it would even scavenge carcasses to survive, showing its opportunistic feeding habits. Coelophysis was a small, bipedal, carnivorous dinosaur that lived on land.
They were up to 3 meters long, with a compact and lightweight body, due to a hollow bone system. This was one of the earliest known dinosaurs in history, living in the late Triassic and early Jurassic.
Around 228 to 200 million years ago, or by other estimates, 28.5 to 19.8 million years ago. This reptile was common in North America, especially New Mexico, and also in South Africa and Zimbabwe. Compared to the large Dilophosaurus of its time, Coelophysis appeared much smaller. They had a maximum length of 3 meters, stood about 1 meter tall, and weighed around 30 kilograms. Coelophys's teeth were typical of carnivores, thin, backward curved, and sharp with small serrations. Despite being carnivorous, Coelophysis's hunting strategy differed from larger Jurassic dinosaurs. Instead of solitary hunting, they tended to hunt in packs, ambushing and surrounding prey. At the end of the Triassic and early Jurassic, North American valleys were mostly deserts.
But green oases still existed on plateaus, mountainous regions, and hills.
In these areas, Coelophysis packs hunted by chasing and encircling their prey. Scientists hypothesize they used special sounds to communicate while hunting, creating a primitive hunting tactic.
Coelophysis likely cooperated to take down larger herbivores, demonstrating complex social behavior.
However, their main diet included small animals, reptiles, and lizards, as evidenced by fossils.
Fossils of Coelophysis are often found with small animal remains, indicating they hunted smaller prey.
An interesting event in Coelophysis research. For a long time, they were thought to be cannibalistic. This stemmed from fossils found at Ghost Ranch, New Mexico, where baby Coelophysis were found in adult stomachs. However, by the early 2000s, this hypothesis was rejected. Later studies showed the small bones belonged to Hesperosuchus. This meant Coelophysis was not cannibalistic, but hunted other small reptiles for survival.
Ghost Ranch is not only rich in Coelophysis fossils, but also has the most primitive crocodile fossils. This site contains a giant dinosaur graveyard with numerous Coelophysis skeletons, raising questions about what happened. While the exact cause remains unclear, some theories suggest a natural disaster, like a flood or drought. This disaster may have killed entire Coelophysis herds, burying their bodies together over time. Another small but notable dinosaur of the early Jurassic was Lesothosaurus, named after Lesotho in Africa. Lesothosaurus lived around 199 to 198 million years ago and was one of the smallest dinosaurs of its time. Its body length reached up to 2 meters. Its height varied from 40 centimeters to over 1 meter. Weight also ranged widely from 3 to 10 kilograms, which was quite normal for its genus. Lesothosaurus moved on 2 long, strong legs, allowing it to reach incredible speeds.
Its 5-fingered forelimbs, though small, were well developed. The 5th finger was underdeveloped, like a human's pinky.
These forelimbs allowed Lesothosaurus to grasp and hold the plants it ate.
This light, sharp structure was unsuitable for crushing hard food, but ideal for cutting soft stems or leaves. Lesothosaurus's slender, lightweight body resembled its ancestor, Ichthyosaurus, a primitive bipedal reptile. Its long, slender tail helped maintain balance during rapid movement. In general, its short skull and streamlined body
made Lesothosaurus look like a bipedal lizard running on the ground. a feat some modern reptiles can still do.
Tectonic was a very agile animal. At the slightest sign of danger, it would immediately flee. But did it have any enemies? Of course it did, at least the predatory Coelophysis. Coelophysis had long, agile legs, easily catching up to Dilophosaurus. Dilophosaurus had no defensive weapons, no sharp claws, no protective armor, no fangs. Another small but very interesting dinosaur was Lycorhinus, with many strange features puzzling paleontologists. The name Lycorhinus, from Latin, means wolf face. This comes from the sharp fangs found on its jaw fossil. However, the rest of its dentition indicated it was a herbivore, an unusual combination. Lycorhinus lived in the early Jurassic, around 199 to 196.5 million years ago, in what is now South Africa.
Its body length reached 1.2 meters, height about 50 centimeters, and weighed up to 10 kilograms.
It moved on two legs, similar to its close relative, Heterodontosaurus. Strong, light legs and a long tail for balance. Well-developed forelimbs could grasp plants while eating. Lycorhinus's skull was teardrop-shaped, with a hard, bird-like beak at the front. Immediately behind the beak, it had large, sharp fangs. Scientists initially thought Lycorhinus was a descendant of Synodontia, but after closer analysis, they realized Lycorhinus was an omnivore, eating both plants and small animals. Lycorhinus's diet included succulent stems, ferns, and horsetails. It could also eat insects or small animals. Despite sharp fangs, Lycorhinus was not a formidable predator. When attacked, it could bite back. But only its speed and camouflage helped it escape predators.
Many people overthink all dinosaurs were gigantic, but in reality, they were not.
Many species were only the size of a chicken or lizard. For example, Othniellosaurus.
Othniellosaurus was a small dinosaur from the Upper Jurassic in North America, weighing about 15 kilograms.
If we knew the large carnivorous Dilophosaurus, to see the giant herbivorous dinosaurs, let's go to Laurasia. In Yunnan Province, China, during the early Jurassic, around 203 to 168.3 million years ago, there was a large herbivorous dinosaur named after this locality, Yunnanosaurus.
Its body length reached 13 meters, height about 4.3 meters, and it weighed up to 3 tons. This was much smaller than the giants of later periods, which weighed tens of tons. But in the early Jurassic, Yunnanosaurus was considered a large dinosaur. Yunnanosaurus primarily moved on 4 legs, but could also stand on 2 for a considerable time. This allowed it to reach high branches or raise its forelimbs to threaten approaching predators. Its forelimbs were quite large and resembled its hind limbs, ending in impressive claws.
At the end of Yunnanosaurus's long neck was a small, slender head. The most distinctive feature was over 60 spoon-shaped teeth in its jaws.
When its mouth was closed, these teeth fit together and self-sharpened, allowing it to easily tear leaves.
Notably, this feature was uncommon in primitive dinosaurs like Yunnanosaurus. Instead, it appeared later in giant sauropods like Brachiosaurus, an example of convergent evolution. If paleontologists only found Yunnanosaurus's teeth, they might mistake it for some carnivorous sauropods.
Yunnanosaurus moved from one natural grassland to another, not overly picky in its diet.
Thanks to its specialized teeth, it could pluck leaves from tall trees or eat low ferns and horsetails.
Unisaurus likely lived in herds to enhance its defense against predators.
This phenomenon can still be seen in African savannas today, where buffalo herds sometimes force lions to flee.
At the end of the early Jurassic, Earth began to cool. Some areas were covered by ice. But the ice was not strong enough to affect mammals, as most were fur-covered and lived in caves. However, this cold snap negatively impacted dinosaurs, as they preferred warm climates. Not all species could survive this cold period. For example, Coelophysis, a small carnivore, gradually disappeared.
There are still many incredible reptiles from the early Jurassic that humanity has only partially discovered.